And we're back to look at some trig problems. So if I look at this first problem, it just says find the missing angles and sides. So I'm missing this hypotenuse right here. I don't know the value of that. And then I'm missing both of these acute angles right here. So I like to work my way outside in. So if I'm trying to find the hypotenuse, I don't know any of the angles, so I can't use trig. If I don't know one of these angles, I can't use trig. But I do know that this side is 7 and this side is 15. So this goes back to an older tool that we learned. If you know two sides and you're missing a third side, then we can just do Pythagorean Theorem. We can do a squared plus b squared equals c squared. So I'm missing the hypotenuse, which means that I'm missing c. So I'm going to do 7 squared plus 15 squared equals c squared. So now I'm just going to go to the calculator, type all of that in. So that would be 49 plus 225 equals c squared. And it's not a perfect square. So 49 plus 225 is 274. If I go to square root that in the calculator, I get 16.55, which is the hypotenuse, is the longest side, but I'm going to go ahead and put this in radical form. So if I square root both sides for some practice, I'm not going to say 16.55. I'm going to put it in radical form, which means that I need to break down this radical. So 274 is 2 and 137. And then I'm going to see if 137 breaks down. So 137, trying a few different things. It doesn't. So like 2, that doesn't break down at all. 137 doesn't break down at all. So I'm actually just going to leave my answer as the square root of 274. So that missing side over here is just the square root of 274. I'm going to leave my answer just like that. Attempted to make a factor tree, but there was nothing that it factored to. Okay, now I need to find my missing angles. So now I want to find the missing angles. I'm going to go ahead and label this one angle N as X. And this goes back to what we were talking about. If I'm missing an angle and I don't have enough information to add and subtract from 180, which I didn't, I can do backwards trig. So I'm going to go ahead, I'm using angle N, which means that 7 would be my opposite side, 15 would be my adjacent side. And let's just pretend, like, what if I wasn't right? So then I'm not going to use that side. I'm going to use the sides that I was given. It just leaves less room for error. I'm not going to do what I did just in case I make a mistake. So if I have opposite and adjacent, that would be tangent. Remember TOA. Remember, you don't have to memorize these formulas. You just have to know how to use them. So that would be tangent of x equals 7 over 15, opposite over adjacent. So now whenever we're looking for that angle, we're going to go to the calculator and figure out what that is as a decimal. So 7 over 15 is 0.46 repeating. And now remember, we're going to go to our trig chart, and we're going to look for that number in the tangent column. We're going to look for what's closest to 0.46 repeating, which I see right there, which would make that angle 25 degrees. So I'm going to say that the measure of angle N is about 25 degrees. Okay, now I found this missing angle. I found that missing side. The only thing that I'm missing now is angle M. Well, if I know that this is 90, and I know that this is 25, and I remember that a triangle adds up to 180, all that I'm going to do is add 90 and 25, which is 115, and then subtract that from 180, and then that's going to give you the answer. So I'm going to give you a minute to do that. And you should get that the measure of that angle is, and we'll use that approximately again because we did round, is 65 degrees. And that's how we find those missing angles. So think you've got all these things in your toolbox. You've got trig, you have trig inverse, which is like backwards trig. You have Pythagorean theorem. We still have special right triangles. If you have a isosceles right triangle or a 30, 60, 90, we still have those in the mix. So we just need to figure out what tool are we going to use to solve this problem and then actually solve it. So can you find the angle at which the tower leans? This is the Leaning Tower of Pisa. which building should be perpendicular. So this building should be here, but it's off by a little bit. I want to know, like, how much is it off by? Like, what's the angle that it's leaning at? I'm not measuring this angle up here because I want to know how far is it off from where it's supposed to be. So if I were going to circle this angle and I would go ahead and label my sides, 16 would be opposite. 180, that would be the hypotenuse. That would be across from your box. And I'm going to use trig inverse. I really don't have another choice. Remember, if we have our sides and we don't know enough information in the angles, I have no choice but to use trig inverse. So I'm going to give you a minute to think about it. If I have opposite and hypotenuse, think which one would we use? And if you said sine or thought sine, you're correct. So sine of x equals opposite is 16 over the hypotenuse, 180. So now I need to figure out what's 16 over 180 as a decimal, and that's 0.088, and it's 8 repeating, so we're going to round it. Okay, be careful because it's not 0.8, it's 0.08, which means now I'm going to go trig inverse. I'm going backwards, so I'm going to give you a minute. Go look at your chart and see what number is closest to 0.0889. And if you're looking at your chart, you should see 0.0872, which is close enough, which means that it's off by 5 degrees. Now, that probably doesn't seem like a lot, right? Like the leaning tower is really only leaning at about 5 degrees off. But the taller up it goes, the more the more tilted it's going to be. If something's supposed to be perpendicular and you get a tiny bit off, the farther you go, the farther you are away from where you're supposed to be. There was actually a plane that crashed in the mountains because they were, I think, 7 degrees off when they were flying. So that's super, super important. People in jobs like that, they always have to be very, very careful with those angles and those degrees to get those measurements right. So taking a look at a word problem, it says a 16-foot ladder is propped against a building. Ladders lean against buildings. That's the safest way to do it. So if this right here is my wall to the building, this is the ladder. The ladder is the one that's leaning against the building, and then there's the ground right there. So the ladder 16 foot, that would be the hypotenuse. And I also know that the angle that it forms with the ground, so the angle on the ground measures 55 degrees. So I know the hypotenuse is 16 feet. I know the angle with the ground is 55 degrees. How far up the side of the building does the ladder go? So there's your x. Okay, now, we've done a lot of problems. We need to figure out how are we going to solve this. Would this be Pythagorean theorem? I'm missing a side. Could I do Pythagorean theorem? Well, I don't have enough information to do Pythagorean theorem. It's 55, which isn't 45, which isn't 30, 60, 90. It's not a special right triangle, which means that we're going to use trig when all else fails. Now, is it forwards trig or is it backwards trig? Is it normal trig or is it trig inverse? And if we look at it, we're missing a side, not an angle, which means that this would be forwards trig, just plain old normal trig. So I'm going to go ahead and circle my angle. Remember, we always circle our angle, label our side. So I'm going to circle my angle. X would be the opposite. 16, we already said was the hypotenuse, so I'm using sine again. So sine of 55 equals x over 16. Okay, remember, when x is up high, we multiply. When x is down low, we switch and divide. Now, sine of 55, I'm going to go to my chart, and I'm just going to look for sine of 55. If you do it correctly, it's 0.8192. And because x is up high, I'm going to multiply those two numbers together. And it's 13.1072. Now, the problem doesn't tell us what to round to, which means we're going to go 2 decimal places out. So the calculator said 13.1072. If I go 2 places out, that 0 would need to go up because of the 7. So I'm going to say that the ladder is approximately 13.12 in its feet up the wall. That's it. Now, we're going to read through these next problems, and we're just going to figure out what would we use to solve them. So the next one says that the side lengths of a right triangle are 5, 12, 13. There's that triple again. So I'm going to go ahead and sketch out this triangle. I'm going to draw a picture. 5, 12, and the hypotenuse has to be the longest side, 13. Okay, it says find the measures of the acute angles. So the acute angles would be these angles. I'm going to label one as X and one as Y. Okay, now thinking about it. I don't need to do Pythagorean Theorem. I'm not missing any sides. I don't know if it's a special right triangle, if it's 30, 60, 90, or 45, 45, 90. Asking yourself, what tool would we use to find these angles? Could I add and subtract from 180? I don't have enough information. So this would be a trig problem, but not just any trig, it'd be trig inverse. Because I'm going backwards, I'm trying to find those missing angles. And then taking a look at our last one, it says find the measure of angle BDC. So I'm looking for this acute angle right here. If it's a rectangle, I know that these corners are 90, but I don't have enough information. If I knew that this one, sorry about that, if I knew that this angle right here was 50, well then a triangle adds up to 180, 90 and 50, and then that other angle would be 40. But I don't have enough information there, which means that this is also a trig inverse problem as well. So just thinking, if you're missing a side, you have three options. You can do Pythagorean Theorem. You can have a special right triangle, which is the chart. So it's a squared plus b squared equals c squared Pythagorean Theorem. Special right triangles are those charts. Or it could be a trig problem. If you're missing an angle, on the other hand, you only have two options. They're either going to add up to 180, which means that you need a few angles to do that, or it's going to be a trig inverse problem, which means you're going backwards on your chart. So keep all those tools in mind as you're working on your practice, and most of those problems